All right, so I'm going to pick up here on page 9 of the chapter 2 handouts. We're talking about organizing quantitative data now. All right, so grouping and organizing quantitative or numerical data that represents counts or measurements. Okay, and one very important aspect of the distribution of a quantitative data set is its shape. Okay. And often, what we're going to do a lot of, the best way to identify the shape is to approximate it by using a smooth curve. Okay. So we don't necessarily want to look at each individual data point, but we want to look at an approximation. So for example, this is called a dot plot. These are the test scores from Class A. We've already looked at this dot plot before. And instead of looking at each individual point, what we want to do is just try to approximate the shape. So generally, to do something like this, okay, to kind of use a smooth curve to approximate the shape. What you would not want to do in this case is you would never do something like, oh, well, this data is all over the place. It's jumping up and down. Okay. No, you would not do that. We want to just approximate it with a smooth curve. Okay. And the key point here is that we are looking for overall patterns or trends in the data. Here is a good figure from the book that shows, oops, let me get rid of that, sorry, some very common distribution shapes. And we will continue to talk about these basically throughout the class. So we've got, oops, sorry, a uniform distribution right here, where basically every value has the same frequency and it's basically rectangular shapes. We have a bell-shaped curve, okay, where it just kind of goes up and down nicely. It's symmetric. We have a skewed right curve. Okay, so again, we already looked at this. The data is leaning to the left. It's got a long tail out to the right, so we call it right skewed. A skewed left curve. So the data is leaning to the right and it's got a long tail out to the left, so it's left skewed. So what we would do is again kind of approximate these. Rectangular, bell-shaped, nice smooth curve for right skewed, for left skewed. Okay. And again, we are looking for data distributions that approximate these shapes. They don't have to be exactly like one of these, but is it approximately like those? And just a note about symmetry, that basically a distribution is symmetric if the two halves are mirror images of each other. So if we look back at these, we can see that a uniform distribution, if you were to draw a line down the middle, the two sides are mirror images. And also with the bell-shaped, if you were to draw a line down the middle, the two sides are mirror images. So those are both symmetric distributions. All right, so specifically, organizing quantitative data. And again, we're going to start by making frequency distributions. Then we're going to use those distributions to make a histogram. So a frequency distribution, a summary table of data that lists classes or categories or bins of data values. And then for each data class, we're going to list the corresponding frequencies or counts for each class. how many data values fall into that data class. Okay. And in this case, we're going to look at two different methods for how to group the numerical data into classes. And the method that you use depends on the type of numerical data that you have. So there's two different methods. First, for discrete data. So in this case, each data class is going to represent a single possible data value. And then the second method is for continuous data. In this case, each data class consists of a range of values with a lower class limit and an upper class limit for each data class. All right, we're going to discuss each of these two methods in more detail and look at an example for each one. So let's start with the discrete data method. And again, in this method, each data class is just going to be a single number. Because of this, the method will only work if your data is discrete. So in other words, only certain values are possible. And in addition, if there is only a small number of discrete data values in the data set. So for an example, let's look at this data. This is from a class of mine a few years ago. The number of hours of TV that each of my students had watched in the previous 24 hours. I asked you guys a similar question on your survey. Okay. So it's definitely discrete data, and there's only a certain, small number of different data values. So basically, we need to put each of the possible data values. They watched 0 hours, 1 hour, 2 hours. So 0 is the minimum, 8 is the maximum. So we're just going to go 0 through 8. And then we're just going to count up how many data values are in each category. Okay, so how many occurrences are there of 0? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. How many occurrences of people that watched 1 hour? 3. And so on. For 2, there was 7 occurrences. For 3, there was 6 occurrences. For 4, there was none. Nobody watched 4 hours of TV, but we can't skip over it. We still have to include that data value, because if we just skipped it, then it would change the shape of the data. We need to include it and just put a frequency of 0. 5 hours, there was 4 people. 6 hours, there was 2 people. 7 hours, again, there was 0, but we have to include that. 8 hours, there was 2 people. Okay. And notice that there was a total of 32 data values in the list. Okay. So now what we need to do is calculate the relative frequency. And again, that would just be the frequency for the category divided by the total number of data values. So for example, 8 divided by 32, in this case, that divides out exactly to 0.25. And so on. You would continue to calculate the relative frequency in decimal form for each category. So in this case, 3 divided by 32. That would be 0.09375. 7 divided by 32 would be 0.21875. 6 divided by 32 would be 0.1875. Obviously this one's 0. 4 divided by 32 would be 0.125. 2 divided by 32 would be 0.0625. And that's a 6. This is 0. And then again 0.0625. All right, and then again to get from the decimal form to the percent form, just multiply each of those by 100. Okay, so this would be exactly 25%. This would be 9.375%, and so on. Instead of writing these, I'll just say them. 21.875, 18.75, 0, 12.5, 6.25, 0, and 6.25. All right, now that we've got our frequency distribution, we're going to use that and make our histogram. Specifically, for a histogram, the bars should be touching each other as opposed to the bar charts that we made earlier. And for the discrete data grouping, we're just going to put each number, each data value, right underneath each column, okay, centered under the bar. All right, I'm going to erase all this and go on to the next page, so pause it if you need. All right, so notice here that we're plotting the relative frequency in percent, okay? So those numbers that we just calculated, we're going to go ahead and make our histogram now. Disregard this first empty column. Excuse me, that's kind of a holdover from our previous book where they wanted an empty column. In this case, it doesn't really matter. So for the TV hours of 0, and again, notice I've put the data values centered under each column. It was 25%. So we're just going to go ahead and make a column. Oh my gosh, this is not going to come out great. You guys can do a much better job on your paper. 25%. All right, so there's our column for that category. For 1, it was, what, 9.375. So that's whatever, about here, almost 10, but not quite. For 2, it was 21.875. So that's going to be, what, about here. For 3, it was 18.75. That's going to be, what, about here. For 4, it was 0. For 5, 12.5. So that's right here. For 6, it was 6.25. That's what, about here. For 7, it was 0. For 8, it was 6.25. All right, so kind of like that. I did the best I could here on the computer. All right, so now that we have the histogram, just by looking at it, we can make some conclusion statements. And, there could be a number of different things you could say about the data after looking at this. You could say, first of all, well, more students watched no TV than any other amount. You could say something like the majority of students watched less than 4 hours of TV, whatever. You could come up with a number of different conclusion statements. The distribution shape, well, just by looking at it, we can see it's kind of shaped like this. The data is definitely leaning to the left, which makes it therefore a right-skewed distribution. Okay. And also just a note down here at the bottom that it doesn't matter if you plot the actual counts, the frequency in decimal form or the frequency in percent form, the shape will be the same. But typically we want to plot relative frequency, either in decimal or percent, because that way you can compare different data sets that maybe have different total frequencies. Okay, the only way you can compare them fairly is if you convert them into relative frequencies. So we typically want to do that. All right, again, I'm going to erase all this and go on to the next page. So that was discrete data grouping. Now we want to talk about continuous data grouping. And we're going to use this if the data set consists of a large number of different discrete data values, like if there's a lot of different numbers. In the case we just did, it was only 0 through 8. That was manageable. If you have a whole bunch of different numbers, then you're going to want to group them. Or if the data is continuous, which generally would mean that you have decimal numbers. Okay, so what we're going to do in either of these cases is we're going to create data classes by using intervals or ranges of numbers. Okay. So here are the various terms that are associated with continuous data grouping. First of all, a data class. So each different category is a data class. Okay. The class limits. The lower class limits are the smallest numbers that belong to each data class. The upper class limits are the largest numbers that belong to each data class. The class width is the difference between the lower limit of a data class and the lower limit of the next higher data class. And I'll show you exactly what that means, okay? A few guidelines on how to group the data. First of all, you want the number of classes to be small enough so that it actually summarizes the data, but large enough to show the characteristics of the data. So the usual rule of thumb is somewhere between 5 and 20 data classes. Okay. Each data value must belong to one and only one data class. In other words, you cannot have overlap of data classes. Whenever possible, and I would say essentially always, all of your data classes should have the same width. They should, have the same width. Okay. So let me show you just a few examples of how you might set up your data classes. Let's say you've got data, it's continuous data, and maybe the numbers are between 0 and 100. Now maybe if your data was in integers, you might want to use a class width of 10. Okay. So in other words, I would start my first data class with the lower class limit of 0, and with a class width of 10, that would mean that the difference between this data class and the next bigger data class has to be 10. Okay? And so on. Each time I want to increase that lower class limit by 10. So the next one would start at 20. All right. Now this data is in integers. So basically my first data class would just be 0 through 9, 10 through 19, 20 through 29, and so on. Okay. And if I want to go all the way up to 90 through 99, like that. So that would be a class width of 10, and again, you see that class width here. And also here. The difference in each case is 10. Okay. Now, supposing that maybe my numbers were given to the first decimal place. So maybe I had a data value in there that was like 5.9 or 19.9. Okay. In this case, these data classes are not going to work because the data is given to the nearest tenth. The data classes have to be given to the nearest tenth. So in this case, I would have to go 0 through 9.9. And then because I'm going to list this to the nearest tenth, I should go ahead and put this here. And then I would have 10.0 through 19.9. And then I would have 20.0 through 29.9. Okay. Because I want to make sure that every data value, say 19.9, will fit in to one of these data classes. This would go into this data class. But here I've got a gap between 19 and 20, so I'm not sure where to put 19.9. And so on. If your data goes to 2 decimal places, like this, then your data classes, sorry, that should be a 0, have to go to 2 decimal places, like this, and so on. Every time you would have to add another data place of accuracy to your data classes. All right, I'm going to erase all this, go on to the next page. All right, so let's do an example now using the continuous data grouping method. This is the data we're going to use. This is data from StatDisk, and it's actually from the 12th edition. So if you're in StatDisk, you would have to go to Data 12th edition, and it is from the men's body measurements data file, and specifically we're going to look at the weight data. So this is, they took 40 guys and they weighed them, and this is their weight in kilograms, not in pounds. Okay, so in the first column I've just got the data points numbered 1 through 40. This is the weight in kilograms straight out of the StatDisk data file. And then for our purposes, what we want to have is the data sorted in order from smallest to largest. So this is the data column we're actually going to use. It's the same data. I just sorted it from smallest to largest. Okay. So the first thing we need to do is to set up our data classes. Okay. So we need to start by maybe figuring out what class width we want to use. and what starting lower class limit? Where do we want to start our first data class? Okay. So by looking at the data, the smallest data value is 56.2. So we need to start below that. And a convenient place to start might be 50 kilograms. We could start at 55, but it's even easier maybe if we start at 50. Okay. And then we need to think, well, what class width are we going to use? Because our class width will kind of determine how many data classes we end up with. Okay, so let's just think, if we started with a class width of 10, then in other words, our first data class would be 50 through something, and then with a class width of 10, okay, we would be adding 10 to each lower class limit. Then our second would start with 60 through something, 70 through something, and so on. And our last data class, we have to get high enough to incorporate the last data value. So the last one would be 130 through something, okay? And that would wind up giving us a total of 9 data classes. And that sounds pretty good. Remember, we said we wanted to have like between 5 and 20, so 9 sounds about perfect. So we're going to go with a class width of 10. That's going to give us 9 data classes. Okay. Let's see. I think on the next page we're going to write all those out. And then what we're going to do is tally up how many data values fall into each data class. Okay. All right, I'm going to erase and go on to the next page. All right, so right here, let's go ahead and fill out all of our data classes. Like I said, we're going to start with 50. And then our next one will be 60 and 70. I'm not going to type or write all this out, but 80, 90, 100, 110, 120, 130. Okay. Through. All right, and then again, if you look back on the previous page, the data is given to the first decimal place. So in other words, I can't just do 50 through 59. I need to make it 59.9. I need to go to that 1 decimal place of accuracy. And because of that, I'm going to make this 50.0. All right, and then likewise, we're going to have 60.0 through 69.9. So again, you know, the first column here, these are the lower class limits. The second column, these are the upper class limits. And then you're going to continue 70 through 79.9. 80 through 89.9, and so on. So go ahead and continue filling those in. The last data class would be 130.0 through 139.9. And then all we need to do is go back to the data and count up how many of the data values, for example, fall between 50 and 59.9. Well, let's go back to the data and look at it. So between 50 and 59.9, sorry, that's going to reappear, would be 59.9 would fall right here. So in other words, I've got 4 data values in my first data class. How many fall through 60 and 69.9. So 69.9 would be right here. So there's 1, 2, 3, 4, 5, 6. And so on. Continue doing that. You know, just draw lines between each data class, count up the data values. Let's go back here and fill in. Oops, okay. How am I going to get this? Oh, crap. All right, you know what? I'm just going to erase all this and just fill in the frequency columns. You've already got your data classes. So we've got a frequency of 4, 6, 10, 10, 3, 3, 2, 1, and 1. And this is a total of 40 data values, which is what we started with in the list. You should always just add these up, make sure you didn't miss any. Okay, then we're going to calculate our relative frequency in both decimal form and percent form. So for example here, I would do the 4 divided by 40. Okay, so that's exactly 0.1. Multiply that by 100, and that is 10% exactly. I'll just go ahead and write 10.0. Or for example here, I'm going to do a frequency of 6 divided by the total number of 40. Okay, that divides out evenly to 0.15. Multiply that by 100. That is exactly 15%. And so on. Just keep taking your frequencies divided by the total number of data values, which is 40, to get your relative frequencies in decimal form. Multiply them by 100 to get the relative frequencies in percent form. So we should have 10%, 15%, 25%, 25%, 7.5, 7.5, 5%, 2.5, and 2.5. All right. Pause that if you're not done writing it all down. I'm going to erase and move down so I can go ahead and make the histogram. All right, so again, just using those relative frequencies in percent form, we can go ahead and make the histogram. We're going to label these, in this case, using the lower class limits. So our first lower class limit was 50. Okay, so for that category, from 50 to 50.9, we had a relative frequency of 10%. So that is exactly here. All right, so like this. Oh God, that's terrible. Sorry. Again, you guys can do much better on your paper. The next category started at 60. That was a relative frequency of 15%. And so on. So just carry on, make your own graph. You can look at mine when you're done. 70 was 25%. 80 was also 25%. 90 was 7.5, so that's right here. 100 was 7.5, that's right here. 110 was 5. 120 was 2.5. 130 was 2.5. All right, so it should look something like this. Add the rest of your labels down here. On the left-hand side of each column, I would put 80, 90, 100, 110, 120, 130. Notice how I've got a title, men's weight data. I've got the x-axis labeled, weight in kilograms. Those are the measurement units. It's important to always include those. And then I'm indicating over here that this is the relative frequency in percent. All right, so what can we say about the distribution shape? And again, we're just looking for general trends. So, if we kind of went like this, it's definitely leaning a little bit to the left. There's more data on the left. So I would say that this is maybe a little right skewed. It's not severely right skewed, but it's not exactly symmetric either. So definitely a little bit right skewed. Okay. All right, I'm going to erase and go on to the next page. Just a couple comments about making a good frequency distribution. And I'm going to fire up StatDisk in just a minute here, and I'll show you how to make these in StatDisk. So this is the StatDisk histogram that we just made. All right, we just did this by hand. This is frequency instead of relative frequency. But this histogram, the way we made it, is pretty good. There's a decent number of data classes here. Now, here's what can happen if you don't have the right number of data classes. Down here, this is the same data, but there's only 3 data classes. It's not enough, okay? We're just not clearly seeing the distribution of the data. And then over here, maybe this is just kind of overkill. There's too many data classes, really. We don't need this many, because what happens when you do this is you just have too much of the data jumping up and down. It's kind of hard to see exactly what's going on. Versus up here, where we just kind of could really see the general trend of the data. Okay. All right, I'm going to take a break for a minute, and then I'll come right back and show you how to do this in StatDisk. All right, so let's look at this exact same histogram we just made, but this time we're going to use StatDisk. All right, so I just opened StatDisk, and then like I said, there are data sets preloaded in here. The one I used was from the 12th edition. It was from, the Body Measurements Male. Okay. The column we were looking at was column number 10, the weight. So the first thing I'm going to do is I'm going to go up to Data, Histogram. Okay. We want to plot column 10, the weight. I'm just going to let StatDisk auto-fit it. Okay, that's the default. So I'm just going to hit plot, and we'll see what happens. All right, so that's what the histogram looks like. And then what you can see, these are just the frequencies in counts. So it will count up how it set up the data classes. There's 10 in the first data class, 20, and so on. All right, so let's change this. So I'm going to come down here to user defined. Let's change it to the way we just did it. We used a class width of 10 and a starting lower class limit of 50. And then let's hit plot. All right, there you go. So that is exactly the histogram that we just made. And just so you know, you can come down here, you can change between frequency and relative frequency in percent. Now, the only thing I don't like about the relative frequency in percent is that it always just rounds it off to integer values. Okay, so let's just go back to the counts. And you know, sometimes how you define your class width and your starting lower class limit can change how the histogram looks. Let's try a couple different ones. Let's try what happens if we change to a class width of 15 and plot it. Okay, you know, still looks pretty good. Definitely still looks right skewed. If I change my class start to 45, and if I plot it, in this case, you know, it's almost looking more bell-shaped, symmetric, as opposed to being very skewed. So sometimes just how you set up your data classes can affect how the data distribution looks. All right, and then the other thing I want to point out is, like I said, always make sure that you include a title. So this is men's health data, weight. All right, and as you type that in, you can see it went ahead and added the title here for me. I'm going to label my x-axis weight in kilograms. Okay. And then StatDisk will always already have the y-axis for the histograms labeled for you. In this case, it's just frequency. Okay, now while I've got this up, the last thing I wanted to tell you about is how to print out these plots, the histograms and the scatter plots. Now you can see down here they have a print and a copy button, but I do not want you to use those, and here's why. I'm going to go ahead and start up, I'm going to bring a Word file over here, okay? If I hit, say, copy, and then if I go to that Word file and I click in there and I paste it, I'm just going to do a Control V. So here's the problem. Sorry. It only shows me the plot stuff. It doesn't show me this stuff, your input stuff. See, and I want to see that input stuff. So I want you to use a different method. And just so you know, this method is also described in a file I have posted, which is called something like how to print out applet output. There's a couple different methods. I'm just going to go ahead and delete this. The best one is to use the snipping tool. I see I've already got mine open down here at the bottom of my screen. But you know, if you just go start, my snipping tool is right here because I use it all the time, or just go to all programs and it should be here somewhere. It might be under accessories. Yes, snipping tool. So it's like a pair of scissors with a little circle around it. All right. So here's my snipping tool. Where is my snipping tool? All right. So I am going to go new, and it'll give you a little crosshair, and I'm going to click here at the top of what I want to snip, and I'm just going to drag. I'm holding my mouse button down. I'm going to drag, and then when I have it all, I'm going to release. I'm going to come up here, edit, copy. Let me minimize that now. I'm going to come back to my Word file, click, and again I'm going to paste it by doing Control V. Okay? So basically you can just capture anything on your screen and it will save it as an image, and then you can just paste it directly into Word. And then it's nice because once you have it into Word, so I just clicked on it, so it's now in here as a picture and I can do stuff. I can make it smaller if I want, like this. That way you can get multiple plots on a single page if you want. I can change, I always change this to wrap text square because that way I can easily move the picture around to wherever I want it. Okay. So I definitely recommend that you investigate how to use the snipping tool. If for some reason you don't have the snipping tool or you can't find it, you can always just do a print screen, but that is not as convenient. For example, if I just do I think it's a Control-Alt print screen, those are all just buttons on your keyboard. And if I come over here, and again, if I paste it, Control-V, okay. So when you do that, it captures the entire screen. And there's all this other junk that you don't really want. So then you might have to come in here and crop it. Just get rid of all that other stuff that you don't want. So it still works, but it's not quite as convenient as the snipping tool. All right, so that is how I want you to print out all your stuff so that I can see the relevant input options. All right, let's come back to here, see where we're at. Okay, perfect. So what I want you guys to do now, and normally we would do this in class, I have 2 problems and I want you to do them. Okay, I give you some data, just like the examples I just did, and I want you to, first make your frequency distribution, calculate your relative frequencies, make sure whenever you do this that you keep enough accuracy, so keep at least a couple decimal places for your relative frequencies. Make your histogram, and then depending on the level, whether it's the discrete or the continuous, label your histograms accordingly. After you make your histogram, draw some conclusion about the distribution of the data, like we just kind of did. So what you might want to do, for example, is start and do this one first. Okay, this is discrete data, so you're just going to have your discrete numbers here. Come to the next page, make your histogram, how is the data distributed, and then you can stop and check your answers before you go on to the next problem. Okay, the next problem is you're going to use the continuous data method. I gave you your starting lower class limit. I gave you your class width. So based on that, set up your data classes and then go to the data, which is on the next page, count up your frequencies, etc. Here's the data. Here's the grid to make your histogram. Describe the distribution. And then I really want you to think about, considering what this data is, life expectancy for countries in the world. Why is it shaped the way it is? I really want you to think about that, okay? So, again, we would normally do this in class, so what you should do right now is pause and go ahead and do the work yourself, and then just come back and check your answers. So pause, do it. All right, so let's go ahead and look at the first problem, the cottonmouth litter size. So let me just pull over my solutions for the table here. So the number of snakes in the litter went from 1 through 8. And then you just have to go through and count up the frequencies. And again, even though there were not any that had a litter size of 2, you still have to include that as one of your data categories. So your frequencies should be 1013764.2. That was a total of 24 data values. So in each case, you just want to take the frequency divided by the total to get your relative frequency in decimal form. So 1 divided by 24, 0.042, 0, 0.042, etc. Take those numbers, multiply by 100 to convert it into percent. So 4.2, 0, 4.2, 12.5, 29.2, 25, 16.7, 8.3. Presumably you already had those calculated. All right, let me go on to the next page and we'll look at the histogram here. I'm just going to drag a snip over of my histogram. All right, so should basically look like this. And, you know, like we said, for this discrete data method, just put each data category right in the middle below the column. Okay, so 1, you know, there was 4.2%, 0, 4.2%, etc. Okay. To describe the distribution of the data, if we tried to kind of see what the trend was, yeah, the data does look like it's leaning a little bit to the right. So it looks like it is a little bit left skewed. All right. Okay, I'm going to get rid of this and go on to the next page, which was the life expectancy. Okay, so this is the life expectancy for 183 countries in the world for a baby born in 2015. In other words, how long are they expected to live? All right, and I gave you, like I said, your starting lower class limit, your class width of 5. So in other words, your first lower class limit would be 50. Then you would add that class width of 5. So your next data category would start at 55 and so on. Keep adding 5. So this would be 60 and so on. All right, I'm going to bring over a snip of those results. Sorry, just give me 1 sec to get this. Here we go. All right, and I just noticed, actually, I've just got plain old 50 through 54.9. Really, I should have 50.0. And really, I should have 55.0, and so on. Okay, the data was given to 1 decimal point. That's why we need to have the 0.9, the 0.9, and so on. And then if you just go through the data list, again, count up the frequency, how many are in each category. And again, knowing that there was a total of 183 data values, then calculate your relative frequency, in your case, both in decimal form and percent form. So for example, I just have percent form listed here. 7 divided by 183 times 100, then accurate to 2 decimal places would be 3.83. So just check your numbers real quick. We got 3.83, 7.65, 12.02, 15.30, 23.50, 21.86, and 15.85. All right, I'm going to go on to the next page and we can look at the histogram. Oops. Give me a second and I will pull that over. Here we go. All right, and again, in this case, we want to label, I guess technically, you know, if you just want to put a 50.0 at the left-hand side of the column, in this case, because I made this in Excel, it's just as easy to list the whole data category underneath each column. Either way is fine, really. I don't care. All right, so we've got each category with its respective relative frequency. The distribution of the data, again, looking at the general trend. The data in this case definitely leaning to the right, long tail to the left. Okay, so it's definitely left skewed. And then the question here is why? Why do you think it is shaped like that? Why is it left skewed like that? Okay. And this is a question that, you're also going to have to answer on the assignment, and I guarantee you on the test. It's not just a matter of plotting the data, but thinking about it and analyzing it. Why does it look like that? This is life expectancy for all the different countries in the world. So we can see, there's many more countries, there's higher frequencies up here that have a higher life expectancy, say between 70, to 85. That's good, right? We're going to live longer. So what's going on down here? Why is there this long tail out to the left? Well, in that case, we have to look back at the data. So let's come back here. And if you look at what's going on, the countries that are down here on the left-hand side of the table are these countries, the ones that have a very low life expectancy. And if you look at it, Sierra Leone, Angola, Central African Republic, Chad, etc., basically Africa. Okay, these are all the African countries. Haiti, they're not in Africa, but these, Laos, these countries are all what you would call maybe third world countries. Okay, they're not as developed. The countries that are on the right-hand side of the graph that have the long life expectancies, Japan, Switzerland, Singapore. We're on here somewhere, United States, 79.3, so we're kind of up here. These are all the highly developed countries in the world, okay? So why do we live longer than Africa? Because we have more resources, we have more wealth, we have, access, we have plentiful access to health care, whereas, the countries down here do not. So, overall, the news is good because there are more countries up here that are more developed, that do have better access to healthcare, to food, to clean living conditions and water. And then there are fewer countries down here that do not. And that is why their life expectancy is so much lower. Okay, stick with me, guys. Just 3 more pages, I think. Okay, a couple other types of plots for quantitative data. First, a dot plot. And, we've already seen these because we did the whole worksheet with all the test scores on this. So basically, with a dot plot, you just draw your horizontal axis, basically just like an x-axis, in this case down here for the test scores, the 100 test scores. Just draw your x-axis from 60 up to whatever, 100. You just put a dot for each data value. And if a data value is repeated, then you just stack the dots on top of each other. For example, we have 2 values here that are at 63. Now, an important point here is it has to be a continuous number scale. You cannot skip values. Again, if you don't have a 64 or a 65, you can't just ignore those. You still have to include, each and every number. All right, otherwise you lose the nature of the data. Okay. Again, this is only for numerical data. You would never make a dot plot for qualitative or categorical data, only numerical. So the benefits of dot plots are you still have all the original data. You could recreate the data list from this. They're pretty easy to make. You can really get a great idea of the data distribution in general from making a dot plot. They're kind of fun. You're just making a bunch of dots. What's not to like? The drawbacks, you can only use it in certain cases. You have to have discrete data. You have to have, repeated data values, and often that may not be the case. And honestly, they're not really often used. Like, you wouldn't ever see a scientific report that had a dot plot in it. You've probably never seen a dot plot unless it was in another class. But it is a good way to kind of initially investigate a data set. All right, let me move on to the next page. Stem and leaf diagrams. Again, you may have not seen these before. So in this case, we are actually going to separate the digits of the data. All right, let me just show you an example. And I'm going to use a data set, my student ages. This is from last fall. So just like I do every quarter, I do the survey, I get, how old are all my students. So here is the sorted list of my student ages. So the method here is basically, we're going to separate the rightmost digit from the rest of the digits. Okay? So the rightmost digit in this case, would be the 9 or the 1 or the 1 and the 2. Okay? So we are essentially going to separate the digits like this. Okay, I'm drawing a line. I'm separating off the rightmost digit. Okay? So the rightmost digits are called the leaves. And the stuff on the left is called the stems. Okay? And what we need to do is to put the leaves in ascending order. So that's ascending. In other words, from smallest to biggest. Okay? And as always, I have to show all the stems, even if there are no data values. We can't skip over it if there are no data values. All right, I need to scooch this page down just a little bit, so I'm going to have to erase this stuff and scooch like this. All right, so for example, my first stem, the digit on the left, sorry, I'm drawing right through them, is a 1. Now, the only data value I have would be 19, so the leaf would be the 9. So I'm going to do this. I'm going to put a 9 here. Now, my next stem is 2. Okay, the ages that begin with the numeral 2. So I have a lot of those because I've got a lot of 21s, 22s, all the way on up through 29. So for each data value, I need to list the leaf. So for example, for this first column, I have 1, 1, and 2. All right, let me move on to the next column. 2, 2, 2, 2. So do you see how in each case we're basically just listing the whole number, like 19, 21, another 21, 22, 22, 22, and so on. Okay? All right, so let's keep going with the 20s, 2, 3, 4, and 5. 5, 5, 6, and 6. 7, 7, 7, and 9. All right, so that is all the 20s. So now I'm going to move on to the next stem, the students in their 30s. Same thing, we're just separating the digits like this. So I've got 31, 1, 2, and 5. Okay, so 1, 1, 2, 5, 6, 7, 9, 9. And that's it for the 30s. 40s, I have 42, 46, 47. So I got to put a 2, a 6, and a 7. I did not have any students in their 50s, but I still got to put that 5 there and just leave it blank. I did not have any students in their 60s, got to just leave a blank. I did have one student who was 70. So I got to put a 0, okay, to recreate the number 70, okay? So that is how the plot would end up looking. And, you know, if you look at this plot, if you think of turning it 90 degrees this way, then it would kind of be equivalent to looking at a histogram. Okay, but in this case we're just looking at it in a different direction. So you can clearly see that the age distribution, again, turn it 90 degrees, is leaning to the left. Okay, so in other words, it's very right skewed, which is very typical. This is how the age distributions in my classes always look. Okay. Now, one thing about this, you know, we have a lot of numbers kind of jammed together in these categories. So there is another option for the stem and leaf plots. I'm going to erase this and scooch. And the other option is this additional technique called split stems, which means that you can use more than one line per stem. Okay, so we're going to use exactly the same data as we just did on the previous page, but we're going to use 2 lines per stem. So we're going to split up the leaf digits. The first line is going to have the digits 0 through 4, and the second line is going to have the digits 5 through 9. So in other words, we've split them exactly in half. Okay, so we're still doing this. We're separating that rightmost digit. Okay, but now we're going to have 2 stems. So 1 is our first stem, and in this case I only have the 1, which is a 9. So I'm going to go ahead and put my leaf, a 9. Now for the stem of 2, remember on the previous page, the graph we just made, there was a whole lot of 2s. So this time we're going to split them in half. On the first line, we're only going to put the ones that end in a 0 through 4. So that's going to be through here. So in other words, I'm going to do 1, 1, 2, 2, 2, 2, 2, 2, 3, 4. Okay, so let's go ahead and add those in. 1, 1, 2, 2, 2, 2. Wait, is that enough? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Sorry. 2, 2, 3, and 4. But now, starting with 5, that's going to go on the second line of the stem. So here I'm going to do 5, 5, 5, 6, 6, 7, 7, 7, 9. Okay, so 5, 5, 5, 6, 6, 7, 7, and 9. All right, so now starting with 3, are there any 30 through 34s? Yes, 31, 31, 32. So I'm going to do a 1, and a 2. All right, are there any 35 through 9s? Yes, 5, 6, 7, 9, 9. Okay, 5, 6, 7, 9, and 9. Okay, the 40s. I've got a 42, so that's the only one that's going to go here. Then I've got 46 and 47. Okay. No 50s, but I have to include both 5s. No 60s, but I have to include both 6s. And 70. Okay. So, you know, the effect this has is it's kind of like a histogram using more data classes. It spreads it out a little, and in this case, you know, just gives us even a more clearer picture of the data. It just spreads it out a little bit. Okay.